Myself, I'm Freeman. I'm coordinator of the CEEDs project, which is a European Commission funded project funded by the Future and Emerging Technologies group of the European Commission under Framework 7. There are 16 partners. It's a €7 million funding project, €6.5 million funding project, over 4 years, where there's a focus on how we can use human senses to understand patterns in big data that current tools don't enable, what the applications of that may be, and what the technology can do to support discovery and understanding in big data. I'm also a senior lecturer in psychology at Goldsmiths, the University of London. That's the lab under which I coordinate the CEEDs project. And I also run IT Media Research Limited, which is a spin-off company from Goldsmiths, which I founded in 2002, so we're now in our 12th year, and we do use the same methods as we're using in the CEEDs project to understand how consumers engage with digital media or digital sensors in the physical environment. Okay, so I've got used to explaining to people what CEEDs is over the last couple of years, and so I tried to put it on one slide so you can get the idea of the project in a nutshell right at the start. And the fundamental innovation in CEEDs is that it's addressing the problem of big data, but through monitoring and measuring subconscious processes that are ongoing in the brain. So the reality of human performance is that for a large proportion of what your brain is doing at any point in time, you're not aware of. Okay, so you'll often have heard your name called out at a party, or discover that someone's talking about you at a party, a cocktail party phenomenon, and that's because your brain and your sensory system together are monitoring what's going on in your environment, and suddenly it's something that's relevant enough for you to focus on consciously. It's in your centre of your consciousness, but that processing of the ambient environment and the stimuli in the environment happens the whole time, and so there's processing that at the moment in all our brains we're kind of unaware of and throwing away. No one's making use of it. So the challenge that we're trying to do in CEEDs is say, well, what can we identify that's useful in people's subconscious processing, and how can we apply that to mapping the data space? So what we've been doing in CEEDs is focusing on what implicit measures of user state we can take, whether that's arousal or attention, how surprised someone is, how satisfied or indeed how difficult they're finding something to understand at any point in time. And then we can try and link that to where we can infer that people are looking or focusing on in the environment. So whether it's in the CEEDs experience induction machine, which you'll see shortly, or in a physical environment, with sensors built in, you can understand where people are looking and how, what their state is, what they want to do, how they're feeling, and so on. Okay, the CEEDs approach is then to use this map of the space, so an interest space, a surprise map of the space, to then have what we call the sentient agent. It's basically a narrative engine to guide the user through the environment, and the environment can be a physical environment or a data environment, as you'll see, to direct people to somewhere that's interesting or surprising or so on. And one of the most challenging aspects of what we're doing is looking at how we can guide people's behaviour subconsciously. So if we know that we want to guide people to somewhere that we've identified as interesting in the data or in the environment, then we need to know how can we point them in that direction without saying, look over there and breaking their natural process of exploration. Okay. So from what you've heard already, you'll guess that the project is hugely interdisciplinary. So there's psychologists, computer scientists, engineers, sensor teams, narrative teams, and more. And the applications of CEEDs, I think we'll see by the end of the day, are huge in lots of different areas. So just to show you who the partners are, it's coordinated out of Goldsmiths, working very closely with the other substantial partner in the project, which is University Ponte-Taprel, which is represented here by our scientific director, Paul. Put your hand up, Paul, and you'll meet him better later. We've also got Electrolux in the consortium, who are white goods manufacturing, and we've got a virtual retail showroom with electrolux where people can explore current ranges of fridges and freezers and so on, but we can measure people's implicit reactions to those products. So it's almost a tool to pre-test what could be successful designs. Other partners from around Europe, we've got Teesside from the north, we've got Sussex from the south, we've got Goldsmiths obviously in London, we've got a couple in Barcelona, we've got Technica Catalunya and EPF, and we've got as far east, I think, as Greece and Hungary, and as far south as Italy and Greece. And central to the CEEDs problem is the data deluge, and we try and put it simply is that there's more data out there than we know how to analyse, even with best-in-class tools and really best practice in a whole range of different spheres. So we don't understand how currently we can analyse all the data that exists, and data is growing the whole time. And CEEDs basically is using psychology and consciousness theory, so understanding how people process information both consciously and subconsciously, merging physical and virtual environments, so put people in a physical cave-type environment, it's called the experience induction machine, and we ask people to interact with it in novel ways, and that interaction has a lot of implicit dimensions. So some examples are tracing people's movement, physical movement around the experience induction machine, and using that movement as an interaction device, both implicitly so that people aren't aware of, and explicitly so we can enable people to gesture and move around space to navigate with the data. Central to CEEDs is the experience induction machine, which we'll see a video of shortly, but you can see a picture of on the bottom left of the slide there. Exists at the moment in Barcelona. Within CEEDs, one of the tasks has been to develop a portable CEEDs experience induction machine. We're going to have one at Goldsmiths very shortly in IT Media's lab, but they can be effectively built relatively cost-effectively anywhere, and it's multiple projectors in 3D with active floor and lots and lots of sensors around the space measuring where you're looking, how long you're looking there, your physiological responses, your brain responses, and your physical movement around the space. So together, all of those sensors give us a really good feel for how you're feeling and what you want to do in any space at any time. The idea behind CEEDs is really to monitor signals of surprise and discovery. So I've mentioned already some of the measures that we use, but so when people are experiencing these large data sets, we measure people's responses, both explicit responses and implicit responses, map those responses to the data set, and then use those to, in real time, guide people's attention, conscious or subconsciously, to different areas of interest or potential interest in visualization. So the goal of CEEDs is to open up people's minds to meaning and discovery in data sets that they're not actually aware and wouldn't be aware of without the system understanding them. Okay. Now, one of the challenges that we looked at in CEEDs quite substantially is that if we try and get a map of people's interest or arousal or surprise around a room and a space, then, and a lot of it is done via inference, then we're going to get it wrong some of the time. And so you're going to get areas where effectively they're marked as interesting, but it's just an artifact, it's noise. You know, you've got a phone call at the same time as you're looking over there, and that caused a measure of arousal. So by putting lots of users together, we average out the noise effectively. So individual noise measures disappear because we average over people, so we can identify what's really interesting. Here are some of the sensors that we are using in CEEDs. So lots of standard physiological ones of heart rate, skin conductance, eye gaze, observable behaviours, speech characteristics, identifying people's arousal or stress from the non-verbal aspects of their speech, and brain activity. And I'm going to leave it there for now because Paul's going to blind you some science in just a few minutes. One of the key elements in CEEDs is that the technologies are wearable, and Paul again is going to show you our wearable head and gaze tracker that you can wear in the XIM that tells you where people are looking, and through analysis in real time of that data we can say we can map people's interest around the space. We also got from a company called Smartex, who are in the consortium through the University of Pisa, wearable vests and suits to measure your physiological responses, so it's done in a relatively unintrusive way. And also we have active gloves, which we'll see shortly, so you actually get feedback and you can feel the data as you're exploring it, and you'll get to see that in just a second. So the CEEDs use cases are basically two. One is to communicate known meaning in the data set, so in educational context or for training purposes. The other is to support discovery for experts in new data sets. And I know one of Paul's big motivations as a neuroscientist in the project is to enable and hope to discover through CEEDs something new about the function of the human brain and the neuroscience of the brain. So there's a real desire from end users to use this tool as something more than just a teaching tool, but as a real scientific discovery tool. And I mentioned already that we've got 4 different applications or data sets that we've been focusing on explicitly within the CEEDs project. One is neuroscience. You'll see a short video from me and hear a bit more about it from Paul. Another is archaeology, and that's where we're using CEEDs in quite challenging external environments to help novices and trainees and experts to classify sherds, pottery sherds, in the field while they're out doing their digging and collection of artifacts. It's been used in helping the Bergen-Belsen concentration camp create a meaningful representation of the huge data set of Holocaust artifacts that they have, and Paul will show you a video of that later. I mentioned earlier Electrolux virtual show. So for neuroscience, basically the idea is that we can load a very large data set of hundreds of neurons with millions of connections between them of a model human brain, and we can then ask scientists to interact with that data in real time and understand better the functional and structural characteristics of the brain. And the idea here is that we should be able to teach people better, and we should be able to enable experts to see data differently because we're guiding them to where their subconscious is responding to. One image I just wanted to show is one that we developed on the back of CEEDs, and it's what we call responsive worlds, and the idea is very similar to the core concept I've discussed already. So you have, and this is applicable in many different domains, and the domain I'm talking about here is connected retail, just to try and bring it to life for you. So effectively, the concept that we developed out of it is called emotionally intelligent environments. So environments that respond with an appreciation or a feeling or an inference or a guess as to what you want at any point in time, or respond to positively at any point in time. And in a retail context, you can imagine a customer walking into a shop. Their response is being sensed in real time, so their movement around the store, their facial expression, their posture, their behaviour, their dwell time around different areas of the store. And then you can make an inference as to whether someone's interested or not in a product. The example I normally give here is imagine being in a diesel store, walking around, and the system identifying that actually you really quite like that pair of jeans based on your behaviour and your implicit behaviour, so your dwell time around the space, the fact that you keep returning to it, you keep looking for it. It had access to your profile, it will know what you bought previously, what it may go within your home wardrobe, and if it knows what your personality is, it may also know that you respond well to flattery or to cost saving. So if the system is capable of knowing all those things about you from your profile, then in real time it can make emotionally intelligent offer to you in the shop. So it can say, Johnny, you obviously like these jeans, and you'll look great in them. And so it'll send a shop assistant to me with that as a tip. Equally, they may say to Paul, you look great in these jeans, and we'll give you a 20% discount. And that may be Paul's preference to respond. So you can imagine different responses to different offers being sent to different people, depending on the inferred state of the user. Now, that's applying the same responsive environment concept to retail. We've also looked explored it in relation to exploration for oil fields, which I mentioned just before the session started. And it can be used to manage any, or to improve access and understanding of any large complex data set. So one of the ones that we'd love to see in the experience induction machine will be some air traffic control scenarios where you physically can control the environment and sense the environment using your natural sensory abilities. Just to very quickly wrap up, I just wanted to mention to you what we see as the core features of what is CEEDs. And effectively there are 5 of them. The first is obviously you have to have a representation of some data. It can be environment, it can be a complex multi-dimensional data set like the brain data that we saw. Next is you collect people's responses, both explicitly, so you ask people what way, enable people to navigate consciously, but also measure their implicit responses, and you store that in relation to the data, so there's a relational database between the data and the user response. You can then interpret those reactions and map that as an interesting space or a less exciting part of the data set. And then, according to goals that you set for the system, you can then navigate people through the data sets or through the environment so that you can target specific user states, whether they're a surprise, which is often associated with discovery, or relevance, or appreciation, or satisfaction, which may be more relevant in other scenarios. And then core feature 5 is being able to sort of step back and take a look at the analytics of it and say, okay, what's driving this whole behavior? How can we overlay all the responses that we captured in relation to this environmental data set in relation to the data, and then be able to take a more analytic approach, I think referred to as more old-fashioned approach in the video that we saw earlier. One other element I wanted to just highlight very quickly, some work that's going on by one of our partners in CEEDs in the University of Padua, which is the gestural responses. And here we've looked at the development within CEEDs of a natural gesture lexicon for interacting with immersive data. So you can't obviously interact completely freely and naturally with a system today, but you almost can. And so what they did in Padua was have a look at get lots of people into the lab, get them to imagine and create their own gestures that they identify as natural for opening a fridge door, closing an oven door, for example, or grabbing some brain data, or putting volume up and volume down, or wanting to hear things more clearly, or wanting to focus in on specific areas. So it's user-generated methodology, or video and commonalities are identified to define a gesture lexicon or alphabet for interacting in real time with massive data. Okay, I'm keeping an eye on the time, so I'm going to probably start in just a minute. Just to say, one of the key areas that, and you don't have to see this slide, I'm going to describe the sentiment of it. One of the key areas that we're involved in CEEDs for at Goldsmiths is to understand the value proposition of CEEDs and how we can roll CEEDs out more generally, whether it can be solved as specific components or as integrated solutions. And we're very keen to talk to anyone in the room and get everyone's view in the room as to what's most interesting or least interesting about what you hear, either from me, we just heard, what you hear from Paul next, or from any of our speakers this afternoon. Finally, flash panel cards are in your pack. Anything that you hear from any of the speakers, or that just comes into your mind, or that you come with questions already, we'd be delighted if you could write those down as ideas and comments on those flash panel cards and post them in the box at the back that's labelled flash panel cards. And we'll, during the afternoon talks, generate some themes around which the panels will discuss this afternoon. Again, if you'd like to join one of the panels, if you can just have a word with me or Andrea, at some point. Andrea, can you put your hand up? At some point during lunch or this afternoon to volunteer to come and give your view, whether from a personal perspective or company perspective, is very interesting. Okay, so I'll leave it there. Just very thank you for listening. I can probably take one or two questions, but given the Paul's on before lunch and it's going to be hard to keep Paul to less than 30 minutes, I suggest you save your questions for the panel. But any burning questions, please go ahead. Otherwise, thank you. Just to introduce myself, I'm Freeman. I'm coordinator of the CEEDs project, which is a European Commission funded project funded by the Future and Emerging Technologies group of the European Commission and the Framework 7. There are 16 partners. It's a €7 million funding project, €6.5 million funding project, over 4 years, where there's a focus on how we can use human senses to understand patterns in big data that current tools don't enable, what the applications of that may be, and what the technology can do to support right at the start. And the fundamental innovation in CEEDs is that it's addressing the problem of big data, but through monitoring and measuring subconscious processes that are ongoing in the brain. So the reality of human performance is that for a large proportion of what your brain is doing at any point in time, you're not aware of. Okay, so you'll often have heard your name called out at a party, or discovered that someone's talking about you at a party, a cocktail party phenomenon, and that's because your brain and your sensory system together are monitoring what's going on in your environment, and suddenly it's something that's relevant enough for you to focus on consciously. It's in your centre of your consciousness, but that processing of the ambient environment and the stimuli in the environment happens the whole time. And so there's processing that at the moment in all our brains we're kind of unaware of and throwing away. No one's making use of it. So the challenge that we're trying to do in CEEDs is say, well, what can we identify as useful in people's subconscious processing, and how can we apply that to mapping the data space? So what we've been doing in CEEDs is focusing on what implicit measures of user state we can take, whether that's arousal or attention, how surprised someone is, how satisfied or indeed how difficult they're finding something to understand at any point in time. And then we can try and link that to where we can infer that people are looking or focusing on in the environment. So whether it's in the CEEDs experience induction machine, which you'll see shortly, or in a physical environment, with sensors built in, you can understand where people are looking and how, what their state is, what they want to do, how they're feeling, and so on. Okay. The CEEDs approach is then to use this map of the space, so an interest space, a surprise map of the space, to then have what we call the sentient agent. It's basically a narrative, discovering, understanding, and big data. I'm also a senior lecturer in psychology at Goldsmiths, the University of London. That's the lab under which I coordinate the CEEDs project. And I also run IT Media Research Limited, which is a spin-off company from Goldsmiths, which I founded in 2002, so we're now in our 12th year. And we do use the same methods as we're using in the CEEDs project to understand how consumers engage with digital media or digital sensors in the physical environment. Okay, so I've got used to explaining to people what CEEDs is over the last couple of years, and so I finally put it on one slide so you can get the idea of the project in a nutshell.